Hello, Nurse 10 students. I am going to do another little video on function notation. And before I get into that, I am going to do just a quick review on solving linear equations. This is the solving linear equation. We isolate. That's what we're going to use a lot. We're going to isolate the variables. So if you're solving for x, or if you're solving for t, or whatever letter that you're solving for, you have to get that letter by itself on one side of the equation. So to do this, you do inverse operations. Whatever you do on one side of the equation, you also have to do to the other side. So here I want to solve for a. I need to isolate a. That means I'm going to get a all by itself. I'm going to bring everything else over to the other side. So we do the opposite operation. So this is a plus 17. So to bring it over to the other side, it makes take away 17. So I get 3a is equal to 9. And then the opposite of multiplying, because this is 3 times a, so to get rid of multiplying, I would have to divide both sides by 3. And then something that you could always do, if you're wondering, if you have some little bit of extra time, is you could try this out and see if it works out. So 9 plus 17, that would equal 26. And that's what it was. It's called a left side, right side verification. So we know it's true. Okay, so just going back and talking about functions. Function notation, often we use the letter f at x, but they can use other letters, and then we can build functions within functions. You know, we often think of functions as input-output machines. So you put a number in, and then you'll get a number back out. So the input number can be thought about as the independent variable, or x. That's the letter that we've been using most often. And the output is like your domain or your dependent variable. So function notation, we're going to spend most of our time on this right now. Now, often I think they just use the letter f for function. So f at x is the same thing as saying y. So you could say x comma y. That's what we normally do like on a graph. But we could also say x comma f at x. Because remember, this depends on that. So whatever x is, this number will depend on x. Now I say f at x. I think that's the word I use most often. Some people say f of x. So it's the value of the function at x, like you think of it on a graph, or if you're thinking of it in other situations, you might say value like of f of x. So sometimes people say at, some people say of. Now there's going to be two types of questions that we're going to give you. The first one is when you're given the input and you're looking for the output. So that's the easiest type. The second one is when you're given the output and you're looking for the input. That's the one where you're going to have to do a little bit of rearranging and solving. So say, for example, if we were given a function f at x is equal to 2x minus 5. Now, what I could do is ask you to find, I'll call part A, f at 3. Okay, so if I asked you to find f at 3, you would substitute wherever x is, you would substitute it with 3. Now, order of operations says you got to do the multiplying first, and then do the workout. So f at x is equal to, f at 3 is equal to 1. So we could do this like different ways now. We could say this is the coordinate pair. If we were going to graph this, we would see that 3 comma 1 would be on our graph. We could do it with a big number. Maybe I'll just pick 100 just to make things a little bit easier. So if I do 2, and then if I'm substituting in, I would put times 300. So it'd be 200, take away 5, so 195. So that would be the coordinate 100, comma 195. If you're going to list it like an ordered pair. The other type of question, I'm going to use the same function. So f at x is equal to 2x plus, or take away 5 So the other type of question is when you're given f at x is equal to, let's say, 13. And then what they want you to do is to find x. This one's a little bit more work, and they kind of word it like this. They'll say f at x is equal to some number. Or they might use other letters, like if they're talking about height and time, they might say h at t. So here we're going to find x. So this time we know that the answer is 13. Just like the very first slide I had. Now we need to do a solve. So I'm going to bring my 5 over to the other side. So it's going to become a plus 5 when it comes over to the other side. I guess I'll go with red. So equals 2x. And then now we're going to divide both sides by 2. And you get x is equal to 9. Let's go back to blue here for a minute. Okay, so then if I was going to write that as a coordinate, like we already knew 13, but it's going to be 9, 13. We knew the output, and this time we are looking for the input. Okay, let's look at that in a word problem situation. So it says a photographer has charges $20 and $6 for each photograph. Okay. Let's say the cost, and I'll say P for pictures. So that's a function notation. The cost depends on the number of pictures that I take. Well, it's $6 for every photograph. So that is the variable rate. It's $6 per picture. And then this $20 is a sitting fee. They're going to have to pay that $20 whether they get 1 picture or 0 pictures or 100 pictures. It's going to cost them $20 no matter what. So these are the two types of questions, part A and part B, or part B and part C. Find the total cost for 10 pictures. So I'm going to find the cost for 10 pictures. This is a direct substitution. I'm just going to put 10 in for P, 60 plus 20, and then it would be $80. So if they got 10 pictures, then it's going to cost them $80. Part C is the other type. It said the customer has $100 to spend. So if I was going to write this in function notation, they're saying that they have $100 to spend. How many photos can be ordered? So I'm going to say 100 is equal to 6p plus 20. When I go to solve this, I have to get rid of the 20, so it becomes subtract when I bring it over to the other side. Now I'm going to divide both sides by 6, and the problem with that is 80 doesn't divide perfectly by 6. What are we going to get? Like 13. I think it's like 0.3. I'm doing this without a calculator, but I'm pretty sure it's going to give me a decimal. So 13.3. So that you can't get 13.3 pictures. So if you were doing a word problem, you could say they could get 13 photos. You'd have to round down in this situation because you can't have decimal photos. Some things you can have decimal, like if it's amounts, like at the bulk burn or distance and time. But as far as something like photos, you can't have decimals. Okay. Internet provider charges $20 a month and $2 per gigabyte of data. Write an equation of the function. Okay, so I'm going to say C for cost again, and maybe I'll say C per gigabyte this time. This is the one that varies. Like, I guess this word per is kind of a standout for that. So it's going to be $2 per gigabyte plus $20 no matter what. Same numbers here. Cost of 10 gigabytes, it'd be 2 times 10 plus 20. So it'll be 20 plus 20. So we got $40. Your bill would be $40 if you use 10 gigabytes. How many gigabytes to use for $60? This time what they're telling us is, if I'm going to use proper notation, that's what they're telling us. So 60 is equal to 2G plus 20. To bring this over to the other side, I'm going to make it subtract 20. And then divide both sides by 2. And it would be 20 gigabytes for $60. One last question here. It says the equation negative 0.08D plus 50 represents the volume in liters of gas in the vehicle's tank. The negative is because the volume is going to go down the more you drive. They sometimes talk about equations and then functions. Notice here they didn't put V at D, and this one they did. I don't know. It's such a simple little thing, and I never really even thought about it until I saw this textbook. That's all they mean when it's a textbook question like that. Okay, so they put the little brackets beside it, or they don't. That's the difference between a function and write the equation. Okay, so that's minor. Part D, determine the value of V at 600. Okay, so what does this mean? It's how much gas you have left if you went 600 kilometers. They're telling you the input. So you would put that inside the formula, work it out, and so you would have 2 liters of gas left if you went 600 kilometers. C, they're saying when V at D equals 26, so it's saying if you have 26 liters of gas, how far did you go? That's what they're asking for, D. So this is a substitution one. You would put your final answer as 26, bring your 50 over, turns it to a negative, but that's okay because we got a negative and a negative once they divide 300. So it means you've gone 300 kilometers if you have 26 liters of gas left. Okay, so I'm going to assign some textbook questions and a worksheet to do on function notation. And so just stay tuned for that.